Alright, this will be a quick video on what powers of zero are. And the way I'm going to show a power of zero example is imagine you have x to the third over x to the third, and you were to cancel them all out. We would naturally use those exponent laws and say that's x to the 3 minus 3. You subtract the powers when you have a division problem. So this is x to the 0 if you're using a shortcut. So the question is, what does x to the 0 really equal? And most people guess the answer is 0, which is wrong. What it really equals, if you can guess, it is 1. And the reason for that is if I had done this the long way, x to the third is x times x times x, and on bottom, x to the third is x times x times x. So think about what you would have done. You would have canceled each of these out, but when they all cancel, they don't cancel to 0. Remember, this is 1 times 1 times 1. It's all canceled out to the power of 1. So that's why a 0 power is really meaning 1. So that's what the power of 0 is all about here. So powers of 0, I'm going to put a little note up here. Anything to the 0 power equals 1. Anything to a 0 power equals 1. No matter what it is. Anything to a 0 power equals 1. So if I told you I have 5 to the 0 power, I know right away the answer is 1. If I have 7 to the 0 power, I know right away the answer is 1. Another way I can prove this to you, besides like algebraically here, is I could show you with a pattern. Let's say you had 10 to the 4th power. That means 10 times 10 times 10 times 10. What's 10 times 10 times 10 times 10? Yeah, it's 10,000. If I said I had 10 to the third, you'd say that's 10 times 10 times 10. Well, 10 times 10 times 10 is 1,000. If I had 10 to the second power, you'd say 10 times 10. There's 2 of them. 10 times 10 is 100. If I had 10 to the first power, you'd just say I have 10 times nothing. It's just 10. So look at the pattern here. When I had a 4th power, I had 1, 2, 3, 4 zeros. When I had a 3rd power, I had 1, 2, 3 zeros. When I had a 2nd power, I had 2 zeros. When I had a 1st power, I have 1 zero. So if I was to continue the pattern and say now I have 10 to the 0 power. Well, think about this pattern. There was 4 zeros, 3 zeros, 2 zeros, 1 zero. So how many zeros? Okay, that's a lot of zeros. But the answer is 1. There's not going to be any zeros here. There's going to be nothing because there's 0 zeros. So look at how we just took a 0 off, took a 0 off, took a 0 off, took a 0 off. The pattern kind of proves that 10 to the 0 equals 1. So here's how we use this information in algebra. You're going to get all these weird problems where I might say I have 2x to the 0 or something like that. And right away you should know, okay, well this is just 1. So this is 2 times 1, and 2 times 1 is 2. There's my answer, knowing it quickly. If I gave you a big parenthesis and I said I had 4x to the 5th power, and I put a parenthesis around it and then said to the 0 power, that means the entire thing is to the 0 power. So again, it's 1. Anything to the 0 power is 1. I could make it more complicated. Of course, you can always make things more complicated, but you want to just get this basic idea down. So here's a complicated version, I guess, if you want to look at a little harder one. If you had like 3x to the 0 in a parenthesis, all to the, 3rd power, let's say. Well, start with the inside. What is x to the 0? It's 1. So really, what I have here is 3 times 1 to the 3rd power. And what is 3 times 1? It's 3. So I have 3 to the 3rd power, which we all know is 3 times 3 times 3. And 3 times 3 times 3, you better not say is 9. 3 times 3 is 9, but times another 3 is 27. So the answer to this thing is 27. So you got to be kind of careful. So 0 powers, change it to a 0, and then know that x to the 0 is 1, and then use your power. 3 to the third is 3 times 3 times 3.